Yeah, so hi all, very good evening and welcome back to the fifth week of the TA live sessions for NPTEL, Artificial Intelligence Search Methods for Problem Solving. So this week we will be discussing some questions related to the week 5 content, basically branch and bound, A star and such methods. And since many of you had some requested some queries or posted some queries about greedy heuristic and nearest neighbor heuristic, we'll have a brief overview of those towards the end. So without further ado, let's get started. So before starting, is my audio clear and is the screen visible?
Yes, sir, it is.
Yes,
Yes.
sir.
Okay, great.
Yes, sir.
Yes, sir.
Okay, so this is the first question in front of you. So consider this map of let's say a country named triangle country, and you can think of this graph as a complete graph. For those who don't know what a complete graph is, it is a graph in which every node is connected to every other node. And so here, if you don't see an edge between certain two nodes, you just assume that those two nodes have an edge with a very high weight, let's say like plus 10,000 or something. Okay, and so to avoid clutter, those edges have not been shown in the map, and we are about to apply the branch and bound algorithm. And what do you think would be the lower bound on the cost of the tour that it will begin with? So if you remember, sir had discussed one of the examples with different cities: Chennai, Mumbai, Bangalore, Goa, and so on. And he had discussed the concept of a lower bound. So do any of you recall that, or do you have any idea how you can proceed with this question? Anyone?
Through minimum edge.
Right, that's your answer is in the right direction. So what do we want? We want the lower bound, right? So for every node, we'll consider or we'll have a look at the two minimum edges that might be connected to that node, right? So let me shift to my Jamboard for a better explanation. Okay. So first of all, let us name these nodes so that it is easier for us to address them. So let us name them as alphabets A, B, C, D, so on and so forth. Okay, and this is the table, the same map in a table format basically. Okay, so you can see that, for example, the distance between A to B is shown by this particular entry, which is 12, and which is also the case over here, right? The distance between A to B is 12. So this is basically the matrix representation of this map. And to calculate or to find the lower bound, what we will do is we will look at the, for each row we will look at the minimum two uh, entries in each row. What that means is, let's consider this node A basically. Okay, this one. So we are considering this one, and what are the two smallest weight edges connected to it?
12 and 14.
Okay, 12 and 14, which is A is connected to B via this 12 edge and A is connected to C via this 14 edge. So this one and this one. So we'll add these up. Okay, and this is just edge or path that is, or the segment of the tour that is representing. So 12 represents AB and 14 represents AC. Similarly, for the second row, we'll find the minimum two values, which are 12 and 10, so 22. We'll do that for each of these rows. So in an essence, for every node we have the smallest two edges connected to it, right? This one and this one. So we'll sum these values up and we'll divide it by 2 to get the lower bound. So was that clear, or is there any doubt about it?
No.
Okay, that's great. If it's clear, then if you have any doubts, just let me know. So let's move on to the next question. So yeah, the previous question we just saw that the answer is 108. Now, what do you think would be the actual cost of the optimal tour for the above problem? Now, don't.
Excuse me, sir. What if only there are only like remove all the elements like then only two is left? And what should we consider? Like previous question.
Uh,
Can you just show me the? Yeah, can you just show me the thing?
yeah, let
No,
me
no, the
shift to the
table,
Jamboard.
table. Yeah. So example in this table, if I remove all, just say only A and I is left out. So we are remove all only A and I. Okay,
Uh,
if they say question, because the question was like similar to that. They said remove all, and so what happens if you have consider only HI or AI, whatever?
so we are not removing anything here. So are you asking that what if we had only like only two columns? Is that what you're
Yes,
saying?
yes, sir. Yeah, correct, correct.
Okay, so that would be a very small graph, right? So in that case, you will just go with the two options that you have because that is the only two, those are the only two options that you have.
So we should add and divide by two for that also.
Yeah, yeah. So basically, you are considering two edges connected to each node, right? Two minimum
Okay.
edges. So you have to
Mm-hmm.
divide by two. Otherwise, you might end up adding like considering an edge say twice in that that might happen, right?
Yeah. Okay.
Yeah.
Correct. So basically, for that, if that is the case, then add both numbers like and in the row and including zero. Okay. Say example A H I am having. So then I have to add like 69 and 55. In this case, in the table what you given, if I consider only A H I, so 65 and 69 and 55. I have to add divide by two.
Say I'm giving you a very small example. Let's say we have only two nodes, okay, A and B.
Hmm. Hmm.
Okay.
Yeah. 20 plus 30, 10, 30,
Yeah.
30 by
Basically.
30 by 2, 15.
Yeah.
Okay. Thanks. Thanks, sir.
Okay. So yeah. This is the second question over here. So we just saw a lower bound. So a lower bound basically. So what does a lower bound mean? Can any of you like share your thoughts on that?
The minimum cost of the tour.
Right. So the lower bound means that that is the as one of you suggested that is the minimum possible value that the cost that the tour could have or that any of the tours could have, right? So it can't go below that. Now, what would be an optimal tour for the above problem that we just discussed? Because the lower bound tour that we get might not always be a valid tour, right? Anyone? Any ideas how we can proceed over here? Let's say we start at one of the edges. Let's say A. We start at A, one of the nodes A, not edges. Anyone? Okay, so I would request you to mute yourself if you don't have a question or you don't want to give an answer. Yeah, thank you. Okay, so let's discuss it and see what could happen. So this is the same table, same map. Let's say we are starting at A. Okay, so what is the minimum cost that we could take from A? Which node we could go from A that would
As
B A to B because it just
B
has 12. 12.
plus
okay.
A to B.
Yeah, fine. So we considered A to B. Okay. Now what edge do we take from B then?
No option, only
C.
C is left.
Right.
Only C is left.
So we take BC, which has a cost 10.
10.
Okay. Now which edge do we take?
Oh, now like D, because is it like going back? Uh,
14.
Okay, but if we take 14, won't that
we'll go
cause
back
a
to A.
cycle? Exactly. So if we take this 14 edge, that would cause a cycle like this, right? And we
So
want to
in this
avoid that.
case, we have only one option here in this case then
Exactly. Yeah.
for PSPM.
Yeah. So we have to, when we are C, we have to consider this 77 edge CD.
So already visited node should not be traversed.
Yeah, that's the main whole point behind TSP, right? So you have a set of cities and your task is to start at one of them, find a tour that visits all these cities exactly once and returns to its starting point. Okay,
Correct.
right. So we considered CD. Now, uh, taking inspiration from the point we just discussed regarding the C node, which edge do we take from D here? Do we take the 10 edge or the
E.
14 edge?
14.
14.
14,
Uh,
14.
okay.
14 each.
And
No,
why
no,
do you
no.
think so? Why not 10?
We have to
Because
visit
after
each
that,
place more.
Because in case of if we take the 10-ish, then from that we have to move to F. I think that point is F or
Yeah,
yeah,
that is F.
Because it's
right.
from cycle
So
again.
in that case, now to come back again or to go to another node, another city, there will not be any possibility, or otherwise a cycle would be formed.
Yeah, that is perfect. So we can't take the 10h because after that we won't have any option to go to cover the E node unless we revisit one of the cities or one of the nodes, right? So we can't consider the 10h. So we will consider this one, 14 one, DE. Okay, now we have only one option left. So 12, we considered EF. After this, we take the 92 edge. Similarly, here we take the 10 edge, right? And we fill in the remaining two edges like using the logic we just discussed, and we find that we add all these up to find that the total cost is 296. So was that clear?
Yes.
yes,
Yes,
sir.
sir.
Yes, Ranjit. So to answer your question, yes, you could use the Dijkstra's algorithm, but this question you can attempt in a very like manually also because this is a very small map first of all, and yeah, so you could just attempt it by hand also. You don't need to get into the details of an algorithm. So Josephine, we had appointed A as this particular edge. Uh, can you please mute yourself, ma'am?
Yes.
Yeah, thank you. So Varun, what is the difference between path and optimal path? So a path can be any path, right? Any path that is connecting these edges, and an optimal path is one that is satisfying all our requirements and conditions, right? And it is also low cost path, or the lowest possible path that is satisfying all our conditions and requirements, would be a better way to put it. Okay, great. Okay, so if this one is clear, let's now move on to the next questions. Okay, so this we saw the answer is 296. Okay, so for the next few questions we are going to use this map. So if you had attended the previous week's lectures where we discussed some Manhattan distance and stuff like that, so we had used the same map. The difference here is that note that these edge weights that are given over here, these are not the Manhattan distances, these are the actual costs given for these particular edges, right? So for example, for S, okay, for this particular node S, the Manhattan distance would be different, right? But the actual cost for of going from S to O is 60. So just clarifying that before we proceed to the questions. So is are the assumptions clear? So I'll just state them once more. So this is basically a map showing several locations on a grid. So each of these units, as we discussed in the previous one of the previous weeks, each unit is of 10 units. So here it is, the unit is given as kilometers. So each tile is 10 kilometer cross 10 kilometer in size. Okay, S is the start node and G is the goal node. Okay, and these various of these nodes are connected by two-way edges or roads, you could say. And for this map, the move_gen table returns nodes in alphabetical order. So just to elaborate on that a bit, for example, if we are at this node S, then the nodes that it could go to from S would be E, J, K, and O, right? And the way they would be listed in your move_gen function would be something like this. So S could go to, first would come E, then J, then K, then O in alphabetical order. So this has been given to us. So we could keep this in mind while we are trying to.
No, my question is there because that alphabetical order we would be using when there is a tie. But if tie is not there, like in this case, we will not consider the road cost because in this case, like J is the nearest one and E is after that. And then there is a tie between O and K.
Right,
So
right.
will not
So
it be J, E and then
yeah,
K and
so
O?
we'll get into the details of which node we will select later on. So that will of course
Acha,
be decided by the algorithm that we are using to solve this problem. But
fine.
I'm just stating the assumptions over here that we can assume
Okay.
that the move_gen function is defined in an alphabetical manner.
Okay, fine.
Yeah. Okay. So some other of the assumptions are that, yeah, as you were mentioning, ma'am, then when several nodes have the same cost, we use alphabetical order to break ties. Uh, okay. Also, when the same node occurs multiple times with the same cost, then we use the open sequence number to break ties. So if you don't get it right away, don't worry about it. It'll get clearer as we discuss the steps to the method that we are going to use. And again, wherever necessary, we can use the Manhattan distance as a heuristic function. So with those assumptions in mind, so we will try to apply the branch and bound method, the normal branch and bound variation, which allows for cyclic refinements. Basically, we can go from S to E to S to E, so on and so forth. Okay. So, and we are told to list the 5 nodes, starting from the 6th to the 10th nodes that have been refined by this BNB algorithm. So, is the problem setting clear?
I'm not clear about the last point. Determine the 5 nodes from 6th to 10th node.
Yeah, so I'll just
6 to
elaborate
10th
on that.
because, yeah.
Yeah, so when we construct the search tree for the BNB method, right?
Mhm.
So a number of nodes will be refined in a particular sequence, right?
Yeah.
So the question asks us not to list the first 5 nodes that will be refined, uh,
Okay.
just the
Okay.
6th
Got
to
it.
10th nodes.
Okay.
Yeah,
Fine.
okay. So does anyone want to share their thoughts on how we could proceed with this problem? Okay, so we will discuss this and we'll see that if there are any doubts or so. So a convenient way to solve this using the branch and bound method is to have each node containing 3 pieces of information. Okay, so one would be the node name. Okay, let's say S. Okay, the other would be the sequence number in which it is refined. So since this is the first node that we are starting with, we will have assign a sequence number of 1. This is the first node that will be refined. And the third element would be the cost associated with this node. So are these 3 points clear, first of all?
Yes, sir.
Yes, sir, it is clear.
Yeah.
Okay. So Sindhu, to answer your query, so what we are trying to do here is we are given this map. Okay, we have to start from the S node, we have to reach the goal node, and for finding the path we have to use the branch and bound method. That is the gist of the problem that we are trying to solve. Okay, so coming back to this our node representation. So this is our node representation. Okay,
Excuse me, I had a question.
yeah,
Do we
sure.
get the recorded sessions
Yeah,
of the
you get,
problem solving?
yeah, you will get the recording links to every recorded session uh, so if you go to the Swayam portal, you'll see there's a section called problem solving
Yeah.
session. So you will find all the
Okay.
necessary links to presentations as well as recordings over there.
Okay. Okay. Thank you.
Okay. Okay. So just to clarify a few things before we get into the steps. So what does the cost of the path represent in this case? So what does this zero mean? Do any of you want to share your thoughts on that?
Basically, to reach a city from itself, it is 0.
Right. Now, the thing that we have to keep in mind in branch and bound is, uh, suppose we, okay, let's go to the next stage of the search tree, and maybe that will make it a bit clearer what I want to convey. So going back to the map, this was our map. So what are the nodes that we could go to from S? They were E, J, K, and O, right? So these four are our options. So let's just draw those. Okay, so we have E, J, K, and O. So we are not assigning the sequence number yet because we have not yet decided which of these four nodes to refine next. Okay, and so what would be the cost associated with each of these nodes? So we can conveniently just look at the map and see that the cost associated is, for E it is 40, for J it is 30, and for K and O it is 60 each. So this is 40, this is 30, and these two are 60. Now the thing that I was trying to convey here is that this cost does not represent only the cost of going from this parent node to the child node, right? So in the first stage, definitely it represents only that cost because that is our only option. But suppose hypothetically, if we were to go somewhere from E to another node, okay, which had a cost, let's say, of going from E to this new node was, let's say, 10. So the cost that we would assign to this particular node would be 40 plus 10, 50, not just 10. Okay, so we will just keep this in mind while proceeding with the next step. So was that point clear, or any doubt about that?
So once more,
Sir,
Yes,
is
sir.
the same for both?
10.
Basically, we are finding the path cost up till that node.
Exactly, yeah, precisely. So what we are doing is this cost does not just represent the cost of going from the parent node to the child node. It represents the cost of going from this root node, this S node, till that node that we are considering. Okay, so let's just proceed, and if it's still not, I hope it will get clearer with when we go to the next
Sir,
steps.
is this like
So,
sir?
Sorry.
Sir, is this like g of n plus h of n is equal to f of n formula?
No, that we will use when we discuss the A star method. Here we are using the branch
Okay.
and bound method, right?
So we will pick J, right?
We will pick only the costs that are listed in this map, the actual cost basically.
I was talking about the node
I
we will
think
pick next.
when you would be taking another edge, no, so that would be more clearer.
Are
Yeah,
you
yeah.
sharing the screen?
Yeah.
Yeah, I'm sharing the screen. Is the screen not visible?
It is.
It is
It
visible.
is visible.
Yeah, I was on mobile. I'll move. Stop. Sorry.
Yeah. So let's do one thing. Let's just proceed with the next step and maybe it'll get clearer what I was trying to convey. Okay. So let's just consider these four nodes first, E, J, K, and O. So it is quite apparent that we are going to consider J, right? Because it has the least cost among these. So it'll be fruitful for us to explore or refine this node because it is a promising node, right? Uh,
True.
okay. So we'll assign a sequence number 2 to this node, right? Which basically means that this is the second node that we are refining. Okay, now let's go back to
So,
the, yeah,
so what you're trying to say is that like after we traverse J, and when we have to pick the next node after J, so we will see the cost of the nodes that appear from J and the cost of E, K, and O to compare and pick the node, right?
yeah, we are going to compare all of the nodes that are available to us that have not yet been refined.
Okay, got it.
Yeah. So let's just have a look at the options that we have from J. So till now we found that our J node, let me just mark it by green so that we know that it is a promising node as of now. So this was the most promising among these, right? So we are refining this J node. And what are the options of going from J? So from J we could go to S or A or N, right? These three nodes are possible. And remember that in this particular version of branch and bound allows for cyclic refinement, so it could go back to S, right? So the three children would be A, S, and N. Okay. Now let's just have a look at the cost associated. So the cost of going from J to A is 60, right? So the cost that we would assign to this particular node would be 60 plus 30 because that is the cost we are incurring while we are going from S to J to A. That is what I was trying to convey in the previous point that I was trying to make. Right? So is this clear?
Yes, sir.
Yes.
Yes, so
Okay.
So the costs are additive, right? That like we will just look at each step. That's what you were saying, right?
Yeah, yeah. So we'll consider each of
H,
like for each node, we will consider the cost for reaching that node from the start node, basically. The
is
cost
H
of
of n plus H of H1 of n plus H2 of n.
so what are these H1 and H2? I'm not sure.
H2 of n is 60, that is for A,
Okay.
and H1 of n is 30 from S to J.
Right, right. Yeah,
I
yeah.
mean, can we consider like that, right?
Yeah, yeah, we can consider like that. So basically, so each of these are we are exploring different partial solutions, right? So each partial solution, for each partial solution, it would make sense to add the total cost. So yeah, let's just fill in the cost for the other nodes as well. So for S, okay, so the cost would be 60, right? Because we are going from S to J and back to S, so 30 plus 30, 60.
Yeah.
And for
Next,
N,
70.
yeah, this would be 70. Now, remember we have refined this one, we have refined this one. Now, which among these would you refine next? E, A, S, N, K, O.
S.
S.
No, 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 no. It would be, we have to consider
N,
E,
N.
E, K, and O also.
Yeah. So, as some of you suggested, E would be the next node that we will refine because this is the most promising among these. See, the basic point of branch and bound is that once you have a certain set of nodes, right, among say E, A, S, N, K, and O, you are sure that at least as of now, at this point, you are sure that this cost of going or following, let's say, this particular path is only going to increase henceforth, right? So it will only be greater than 90. So why look into that path when you already have a lower or a more promising path over here, this one associated with 40? Okay, so keeping that in mind, we will next explore or next refine 3. So this will be assigned a sequence number 3. Okay, so was the answer clear? Okay, so we already have an answer, so that's great. We'll have a look at the answer soon. Okay, so what was it clear until this point, until having refining 3 E as the third?
Yes, it's clear.
Okay,
Yes, sir.
great. Okay, so we'll see what are the 3 possibilities from E now, or more, 3 or more possibilities. So from E we could go to A, B, F and S, right? 4 possibilities. So this drawing is becoming too big, so I'll just shift to the search tree that I already have here, right? So this was the first node that we refined, right? S sequence 1 with cost 0. Sequence 1 with cost 1. Can you please mute? Yeah, thank you. Next we refined J, second, with cost 30. Third we refined E with cost 40. And now our options are the children from E are A, B, F and S, with each of them having different costs, right? 130, 130, 130 and 80. And just to be aware whether these costs are correct, we can just recalculate. So the cost of going from S to E was 40, and let's just see what the cost of going from E to A was. It was 90, right? So 90 plus 40, 130. Makes sense, right? Okay, great. So yeah, so now since now that we are at the stage of having refined E, okay, don't look at the options that are given below. So we have till now only refined 3 nodes, let's say till E. And what is the next node that we are going to refine as per the available options? We are going to refine K, because among all the others, this one has the most promising cost, right? So if we proceed in a similar fashion, we are going to refine O next, fifth, and then we are going to get to the nodes that we are interested in for the given question, the node 6 to node, the nodes that are refined in sequence from 6 to 10th in the sequence. So S would be the 6th, N would be 7th, again S would be 8th, A would be 9th and J would be 10th. So our answer, that as one of your friends suggested in the chat, would be S, N, S, A and then J. These are the nodes sequence 6th to 10th that our question had asked. So I'll just give you a moment to have a look at the search tree and convince yourselves. And if you have any doubt, just let me know.
Sir, can you explain the sequencing number part once again?
Yeah, sure.
How 6, 7, 8, 9?
Yeah, basically this sequence number basically represents that. So the first node you refined was S, right? This one, this S. So this was the
Yes, sir.
first node you refined. The second node you refined was J, this J. So this had sequence 2, E had sequence 3, right? K had sequence 4,
Yes.
O had 5, and then this S had sequence 6. Basically after O, this particular node was refined, this one. Okay, so basically we have been asked to give the nodes that were refined at turn 6 6 to 10 basically. Yeah, so this is just one of just one specific thing about the question that I had put in. You might be asked about not 6 to 10, maybe first 5 nodes, or maybe all nodes, and all nodes in the sequence that you are refining until you reach a goal node or something like that. So the question might be different, but yeah, I guess the point is communicated.
Yes. Yes. Thank you, sir.
Sir, what is the question number, sir?
This question was, I guess, the third question of the session. Okay, so any doubts about that, or should we proceed?
No doubt, sir.
Okay, that's great. So yeah, we just saw SNS AJ is our required answer. Okay, so now we'll look at a variation of the branch and bound method that we just saw. So if you remember, the previous branch and bound method was where we had allowed these cyclic refinements. Basically, what I mean to say is, after considering this S over here, let's say, we were still allowing us to go back to S, right? For example, this path, S to J back to S, right? This is this is what we are allowing over here, right? Similarly, we can find another example maybe somewhere over here. So this path, S to J to N, or no, S to J to S to J again, right? So these repetitions are allowed, but in this particular variation, the new variation that we are looking at, such repetitions are not allowed. Right? So basically, once we have refined one node, we will not consider it for refining in any of the next stages. This is the difference between the previous one and the new method that we are going to consider, and everything else is the same in the question. We are still asked to apply the branch and bound method along with this extra condition, and we are still asked to report the nodes from 6th to 10th index that were explored or refined, basically. Or maybe I skipped one of the questions. Anyway, so let's just look at this one. Yeah. So this is what I was trying to say. So I'll just let you have a look at the question. Uh, Let me know if the question is not clear. Yeah, Sindhu, you wanted to say something? Okay. Okay, so I hope that the question is clear. I'm audible, right?
Yes, sir.
Yes, sir.
Okay, great. Yeah, just confirming. So let's just have a look at what could happen over here.
Hello, hello, sir.
Yeah, tell me.
Sir, actually, I'm not understanding. ये question कहाँ की है? ये तो assignment में है ही नहीं.
Swaroop, so yeah, these questions are from the previous iterations of the assignment, right? Can you please mute yourself? Maybe there's an echo. Yeah, thank you. So in these live sessions, if this is the first live session that you're attending, in these live sessions, we discuss questions from the previous runs of this course, not from the particular assignment that you are supposed to submit by tomorrow, I guess. Right? So this is just in order to give an idea of what kind of questions there could be, or give you an idea of how you could approach those questions. Is that okay?
Understood, sir. Understood, sir.
Okay, great. Okay, so I hope the question was clear. So let's just see what difference could happen in the previous approach to BNB and this approach to BNB. Okay, so we started with S, right? This had sequence number 1, cos 0, and then the nodes here were E, J, K, and O. So these would remain the same until this step. E, J, K and O. This had 40, this had 30, and these had 60. Okay, so similarly, we'll again refine J among these first because this is the most promising one. The difference now comes over here. Earlier, what we were doing is from J, we were allowing the option to go back to S, but in this version of BNB, we'll not consider that, and the only two options to go from J would be N and A. Okay, so instead of having 3 children over here, this one A, N, and S, we'll have only A and N. Okay, so with that in mind, can any of you quickly draw the rest of the search tree and give me the sequence numbers, maybe from 1 to 10? I'll give you a moment to try that out. So is the difference clear in the two approaches to the two versions of branch and bound?
Yes, sir. Can you read the questions, please?
The question, okay, give me a second. Yeah, this is the question. Do you want the map? Should I enlarge the map?
Yes, sir.
Yes, please.
Yeah, give me a minute. Yeah, there you go. Yeah. Joseph,
So from so from E, we can again open A, right? Though it was opened under J.
Okay, let us see. From E, yeah, so basically those are two different paths, right? So each of these are representing different partial solutions. So since they are different paths, we could reopen them again.
Okay, sir. Thank you.
Yeah. Yeah,
Hello,
sorry.
sir.
Yeah, tell me.
Sir? Repeat, sir. From where I can get these questions?
So this
These questions are
presentation,
not.
yeah, these are not in the assignment. So these questions, the presentation with these questions will be shared with you. If you just go to that problem solving session link that I just mentioned earlier today in this session, you'll find the link to
Okay.
the presentation as
Today,
well.
today only we'll be sharing, sir.
Yeah, immediately. Yeah, after the session, you'll get that.
One question is there, sir. Can you please get that figure, sir? Earlier figure.
Which question are you talking about?
This question only. That earlier one big figure is there. Big tree-like figure is there.
You want me to go back to the map?
Please, sir. Map, yes, sir.
Okay.
Sir, here you told that from J I cannot go to S. I can go to N and A. How, sir? Why, sir?
Because
it's a underrated figure.
Because that is the assumption we are making in this version of branch and bound. See.
Okay. Please tell me, sir.
Once we refine this particular S node first, okay? Then we refine this node, the J node. Okay?
Okay.
What we are telling in this version of branch and bound.
Excuse me, sir. Sir, just one clarification. Like refine means exploring, right?
Yeah, exactly. Yeah. So once we are refining or exploring this J node, we are not allowing for J to go back to S. Okay, this is not allowed.
It's written in the question also, the same thing.
Exactly. This is mentioned in the question. Whereas in the previous version that we discussed, we were allowing that.
Okay. Understood.
Yeah.
Here I can go backwards I can go.
That is bidirectional is not allowed.
Bidirectional is not allowed. In this question, it is allowed, I think. BNB2 search.
Yeah, so in the interest of time, I would encourage you to explore this. Okay, so we have an answer. Let's check. So
Okay, please.
yeah, so one of your friends is suggested that the first node to be refined would be S. Yeah, that's right. Then J, then E, then K, then O, right? Then N, then A, then F, then again N, and then L. Yeah, that's perfect. Yeah. So
Sir, what you were doing? BFS or DFS? While we were going?
we are applying branch and bound. So this is not
Branch and
exactly,
bound.
yeah. This does build up on the
Yeah.
previous methods we learned, but it's just not exactly BFS or DFS.
Okay.
Yeah, so I would
Yes, sir.
encourage you to like just revisit the lectures once, and you'll probably it'll be helpful to get it more get it to
Sure.
yeah, to get it more clear. Yeah.
Sure. Okay, Ritik, sir. Not issue.
Okay, so yeah, so in the interest of time, let's move on to the next question. So yeah, for this question, the answer, the 6th to 10th nodes would be NAF, NL, as one of your friends suggested. Uh, yeah. So in the next question, what we will do is we'll apply the A star method, and the rest of the question remains the same, right? And the 5 nodes, we have to list the 5 nodes from 6th to 10th index that were refined or explored. So here the difference is, earlier we were only looking at this actual cost from the map, right? But here what we are going to do is, in A star there will be 2 components to the cost, as one of your friends was suggesting earlier in this session, GN plus HN.
How, sir?
Okay, so I'll just elaborate on that a bit. So for example, from a particular node, say you have found a partial solution. Okay, this is a barrier, let's say. You have found some path, some partial solution until this point. Okay, so you
Okay.
actually know the actual cost of the path, this part of the path, basically this part of the path. Okay, but
Fine.
here is your goal node, and you have an estimate of the path, that estimate of the cost of the path that could be from this node to the goal node. So these would be basically your 2 components. So this would be your actual cost till the particular node, till the particular partial node that you had refined, and this would be a cost from the that middle intermediate node to the goal node, this estimated path HN, like you used to do in best first search, if you
Okay, sir.
remember.
Understood. Very clear, sir.
Okay, so let's just quickly have a look at the search tree for that. Yeah, so we start from S. Okay, and note that here the cost is 160, not 0. Why is that? Let's just go back to the map quickly. So initially the cost was 0 because the actual cost of going from S to nowhere is of course 0. But in A star, the Fn, the cost, has 2 components. So while the Gn part is 0, the estimated path, or Hn part, of going from S, or this intermediate nodes, in this case only S is the intermediate node, to G would be the Manhattan distance, which is 160. Right? So if you just count the number of blocks, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 into 10, which is 160 units. So the cost associated with S is 0 plus 160, or 160. So was that clear?
Yes, sir.
Okay, sir.
Okay, great. So the rest of the method works in a similar fashion. So we'll see what are the children of S. So here we have E, J, K and O again, but each of these has a different cost now. So remember previously the cost for E was only 40, right? According to the map, only this was the
40
cost.
plus the Manhattan distance from
Yeah,
S.
exactly. Perfect. So 40 plus the Manhattan distance. You can just calculate the Manhattan distance on your own later, and you will see that the cost now becomes 210. Similarly, for J it is 220, K it is 180, and O again it is 180. Now here comes the use of the assumption that we had made initially, the alphabetical assumption. Right? So here we have two promising solutions, K and O. Out of these, we are choosing to go with K because it appears before alphabetically than O.
So,
Yeah, yeah.
so do we need to calculate the Manhattan distance every time for the node from which we are going to the goal node?
Yeah, so in this case, in A star, you don't need to do that. But again, it would be helpful if you just calculate the Manhattan distance for all the nodes to begin with before even starting with solving the problem. So it'll be easier then for you
Uh,
to go back and refer to it.
so just like initially you have calculated the heuristic value 160 using the Manhattan distance,
Right.
which is HN. So
Uh-huh.
does 160 will be constant for the whole question, or we need to calculate for each node when we are visiting there?
No, no, it will be constant because see, the heuristic function over here, the HN value is the Manhattan distance of going from S to the goal node or any node from the any node to the goal node. So this Manhattan distance or cost from going from S to G will remain 160 throughout because the map is not changing, right? So I'll take another example. Let's say this Manhattan distance from X to G. Okay, so what will this be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
So how you counting 1, 2, 3, 4, 5, 6, 7?
Each
You are
units.
counting the squares. Nice.
Yes,
Okay,
yes,
okay, okay.
yes. Each unit we are
Okay.
counting. Right. So the heuristic HN value is basically the cost from one node to the goal node. Since the destination goal node is fixed, the HN values will remain constant. So was that helpful, Aman?
Yes, sir. Thank you.
Okay, great.
Sir, one silly question. Can I ask?
Sure, sir. Go ahead.
Sir, suppose x to g I am going, so can't I calculate like this 50 plus 60 plus 40?
No, because see, you are making an estimate, right? You're making an
Yeah.
estimate of the path from of the cost of the path from a certain node to the goal node, and the whole point behind
Okay.
estimation is that you are not aware of the actual cost, right?
Okay, okay, okay,
Yeah,
okay.
that's why you are using the Manhattan distance.
So, sir, one more thing, sir. Why we are using only Manhattan? We can use Euclidean distance. So many distances are there. So many distance measures are there.
Yeah, so we are using the Manhattan distance because that's what the question had told us. So if the
Okay,
question had mentioned some other distance measure, then we would have used that.
okay, okay. Thank
Yeah.
you. Okay.
Okay, so just revisiting our A star search tree once. So excuse me. Yeah, this one. So I'll encourage you to just have a look at it at your when you're free, and just get back to me in the next live session or in the discussion forum if this is not clear or if you have any remaining doubts about any component or any element of this search tree. But in the interest of time, I'll just proceed with the next few questions. So is that okay? uh,
Okay, okay. Okay, sir.
So in A star search tree, after K, when you will find K,
uh-huh.
why H has been marked as cross?
Right, so this is basically So for the time being, just ignore that, right? So this is just an after effect of the propagation improvement or something, a version of the A star algorithm. So if you just revisit the lecture, I guess you will find
Okay, sir.
this particular section, but for the time being, you
Okay,
can
okay.
just ignore that.
Sure, sure, sure. Thank
Yeah.
you.
Okay, so I hope that's clear. So I'll just quickly go through the. Okay, so this was the answer for the A star part of the question. You can just verify it yourself. If you have any query, just let me know. So yeah, so since the past few weeks, so many of you had some queries about the nearest neighbor and the greedy heuristic. So after Bhaskaran sir had posted the solutions, so was that any helpful? Any have you resolved your doubts, or should we just go over it once more?
Please go, sir. Please do it, sir.
Okay, so since we have a request, we will just go through it. So Bhaskaran sir's explanation, which I've just mentioned in this slide, is a pretty clear and pretty elaborate explanation. So I'll just go through that once. So in nearest neighbor, what we are doing is basically we are considering A. Okay, we're starting with the first row. So what is the least cost of going from A? This E, right? 3.
Yes, sir.
So we add this edge AE. Okay. Okay. So we have added AE. Now look at the second row. Now with what is the least over here? It's okay. No, not the second row. So let me just draw the graph one. So maybe that will be clearer. Yeah. So you drew this edge AE with 3 cost. Okay, now you have to decide where to grow from E. Okay, so let's quickly look this one. Okay, so let's quickly look at the options available for E. So what are the options available for E over here? Which of these will you select?
D, sir.
D, right. We will select D because, okay, although this 3 appears to be one of the options, it's not actually a valid option because that would make us end up going back to A, which we don't want. So we'll select ED with cost 6 and we will add that edge. Okay, so ED with 6. Now we will look where to go from D. From D, okay, this 4 appears to be a correct choice, but what is the issue if we add DA?
It will make
Like
cycle.
it will become path, but not
Yeah, so
closed path.
if we add this DA, it will become a cycle, which we don't want. So we cannot add DA, we'll have to look at something else. I'll just remove this edge. Yeah. So what is our next best option? Our next best option is D. Which one?
C.
Yep, sir. Yep.
F. F.
F.
F.
Right. F is our next best option. So we'll add DF. Okay. So we will add DF with 7. Next we will look at where we can go from F. From F we can use C, right? Cost 2, pretty convenient. So F to C, cost 2, right? Now from C, where can we go? B, right? We can't go back to F. The only best option is B, right?
Yes, sir.
Okay, we go back to B, cost 5, and then we can close our loop by connecting A to B, and then we can form a tour from this particular graph. So this is basically your nearest neighbor. You can draw the edges on a sheet of paper. We just did that. We had a loop, okay, and we
Sir,
can,
sir,
yes.
well, sir, when closed loop is not allowed, why are you putting a loop at the end? You are connecting B and A.
No, no, no. See, a closed loop is not allowed before we have covered all cities. Okay, but in
Okay,
order
after
to
covering,
complete the TSP tour, we need to close the loop, right? We need to go back to our origin city.
it's like TSP, traveling salesman problem, no?
Yes, exactly.
Okay, 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 okay. Okay, understood.
Archana, yes, this is the same question from the previous week's assignment that you had in this iteration of the course. So, uh, if that's clear, I hope the greedy heuristic part would be easier to understand, because here what we are doing is we are just listing all the nodes, all the edges possible, and we are selecting the least among them. Okay, so
It's clear, sir. It's pretty clear.
okay, Archana, how was the answer incorrect? I guess these could be the two possible tours, right?
Yes, sir. Actually, these are the two tours possible, but on the assignment, the answer which was mentioned is incorrect. That's what I'm saying.
Oh, is it? Is it?
One second.
So
ADFCBE. Oh, one second. ABCFT. One second. Oh, no, no. I think
it is correct, right?
AEBCFT.
It's
Okay.
AEDCF FCB. AEDFCB.
TFCBE, AEBCFT. Just can you just go back to the path representation which you were showing?
Sure.
So
AED
AEDFCB,
FCB.
AEDFCB, right?
Yeah. Yep.
Yeah, but on the, I
But
mean,
previous slide it is different. No, right?
yeah, yeah, you mentioned it differently in both the cases, I think. The map and the.
Here AEBCFT
Okay,
something like.
so this is okay, I get it. So this is the greedy heuristic. So let me just go back to this one. Okay. This is the nearest neighbor thing. Is it okay now?
Okay, nearest
Yeah,
neighbor,
yeah.
okay, AEDFCB.
Yeah, yeah.
Okay, so maybe in the
Yes.
assignment also, let me just
Which
check.
mail is this?
Greedy heuristic.
Yeah, just share.
Oh, okay. Nearest neighbor, okay. I also just got that mixed up.
Okay, yeah, no issues. Even I by mistake showed the greedy heuristic answer. So
Yes.
yeah. So I hope I don't need to go through the greedy heuristic once again, right? So because Bhaskaran sir has given a really like pretty good answer. So uh, I hope any doubts regarding these are now clear.
So if you don't mind, greedy heuristic also, can you just come back on that? Because I think I've got it wrong.
So these answers are available on the discussion forum as well. This blue font answer, I've taken it directly from Bhaskaran sir's explanation.
Okay.
Yeah,
Okay. Let
yeah.
me
Just
just check
have a
that
look
out.
at the discussion forum. You'll find all the answers over there for all weeks, in fact.
Okay. Yeah.
So
Yeah, yeah,
one last.
yeah.
In some questions, we are asked to write F values. The F values, which they are generally means the GN plus HN, which we are using in the A star and when.
Okay.
There is in our assignment there is a question in which we have to mention the F values of the last 5 nodes. Can
Okay.
you please elaborate that type of question?
Okay, so see, I haven't had a look at the assignment for week 5. So, but just have a look at the context in which those questions have been asked. Okay, so if those questions have been asked in a context like directly related to A star or something, then you can surely go ahead and use the F values associated with A star method. If there is some other thing that has specifically defined Fn to be something else, then just Just have a look at it. I'm sure it will be mentioned somewhere in the questions.
Okay.
Okay.
Richard, sir?
Yes, Swaroop, tell me.
Sir, yeah, from where I can get the question paper? I need this question paper also. You are solving the main question paper.
Explain the Jamboard your meaning, right?
Ha.
Yeah, so I'll be sharing that as well in the same link. So there's a
Oh,
link to
question
a
paper also.
particular Google Drive folder. So there you'll find all the slides.
And the question paper also, no, sir? Question paper, main question paper.
Question
Previous
paper.
years, the assignment paper, previous year assignment that you
No,
solved today.
no. You won't find all the like exact assignment paper. You will find these questions that we have discussed in these sessions.
Okay, so sir, these questions will be pretty helpful in the assignment thing because I have not gone through the assignment also till now.
I hope so. So I guess we
Have
have
you?
already covered 4 weeks of the course. So I would suggest if you have missed 4 weeks of the course, then
Yes, yes,
just
sir.
just go through the previous 4 weeks before proceeding to the next few weeks because that will be helpful for you to understand the new concepts.
Okay, and sir, is there any WhatsApp group for this for all the people?
I'm not sure about that. So
Yes, sir,
if
can
you
you make
have
it if you permit?
see, we have a dedicated discussion forum for discussing doubts. So just visit the Swayam website, explore the various
That I know.
options.
That I
Yeah.
know, sir. WhatsApp would be better, sir. We can discuss with the kids only, fellow candidates, whosoever is taking the course.
See, that is up to you guys, but I would encourage you to post any doubts you have on the discussion forum because there, Bhaskaran sir, who is the main TA for this course, can address it precisely. Or if you have any doubts related to the live sessions, then I can address it over there as well.
Okay.
Okay.
Okay. Fine, sir.
Okay. So yeah, thank you all of you for attending, and I'll see
Thank
you
you,
guys
Nikhil, sir.
next
Thank
week.
you. Okay,
Thank
thank you. Bye, sir.
Thank you,
Bye,
sir.
Nikhil, sir.
Thank you, sir.
Thank you.
Thank you.